Hi guys, this is Mrs. Gassler, and in this video we're going to talk about names and formulas of ionic compounds. You are going to need some Cornell paper. I chose the blank stuff because I like to write charts, and you'll also need your periodic table that has the information on the back. Okay, so let's get started. First, make sure your name, date, and class period get here, and we are going to be talking about names and formulas of ionic compounds. And our essential question, surprise, surprise, is how do I write names and formulas of ionic compounds? Okay, so let's talk about writing a formula. I like writing formulas too because, again, I really like following rules. Okay, so the way I've got this one set up, we're going to go one step at a time and we'll look at an example while we do it, and then we'll do a slightly more difficult example, and then we'll be done. So, and I've got these in columns so that the step is next to it. So we're going to look at beryllium nitride and tin 2 sulfate. Okay, so the first thing we have to do when writing an ionic compound is determine the charge of each ion. I can't emphasize how necessary that is. That is the one thing that students forget to do when they're trying to write down a formula for an ionic compound, and that is to find the charge. So I've got beryllium, and nitride is nitrogen, so that's just an N. And so I've got three options for trying to figure out what these charges are. And if it's a tall metal or a non-metal, I look at the column in the periodic table. Remember, we had lots of patterns in the periodic table, and this is just another one. So beryllium and nitrogen are actually, beryllium's a tall metal and nitrogen is a non-metal, so I'll be doing that one. If it's a short metal, the Roman numeral is my charge. And if it's a polyatomic ion, it's in the chart on the back of the periodic table. I'm going to write P table because I'm feeling lazy. Okay. So beryllium is right here. It's in the second column, so it's got 2 valence electrons. Nitrogen is right here. It's in the 5th column, or the 15, so that means it has 5 valence electrons. So now that I know the charges, I know how much electrons are going to have to be exchanged here. So the next thing I'm going to do is I'm going to draw the model. I've got plenty of room here, so I'm going to start with my BE and my 2 dots and my N with its 5 dots. Okay, so in the objective where we're talking about the models, at this point I just have to show where the electrons are moving. So beryllium gives up this electron and this electron. That's not enough for nitrogen, so I need another beryllium. That's not enough for that beryllium, so I need another nitrogen. Then I need another beryllium. This is the point where students say, oh my God, will it ever end? Yeah, ends right there. Okay. So now I know how many of each I needed so that I would end up with zero net charge. So this is plus 2, plus 2, plus 2, minus 3, minus 3. That has to all add up to equal 0. If that adds up to 0, then I've done it correctly. So then all I have to do now is write the formula. So I had 3 of the BEs, so BE3, and I had 2 of the Ns, so N2, BE3, N2, beryllium nitride. Okay. Now I don't have a polyatomic ion in this one, but if I did over here and I needed more, if there's more than 1, I have to put it in parentheses, which I think is going to happen on this one, but I can't remember. But it would look like this. If I needed PO4, but I needed 2 of them, it would look like this. So that means I have 2 of the PO4s. Okay, so let's try this again with our other example, tin 2 sulfate. Tin is SN, and sulfate is one of those polyatomic ion guys over here. Sulfate is SO4. And it gets a minus 2 charge, which means that it has 6 valence electrons. And that's how I was able to determine the charge here in the chart on the back of the periodic table. Tin 2, that's a Roman numeral, so that's going to be my charge, which means it's going to get 2 valence electrons here to give up. Oh, this one's a lot easier than I thought it would be. All right, so I've got tin with my 2 dots and SO4 with my 6 dots. And maybe I should have picked a different one because this electron's going to go here and this electron's going to go here. And so I really just have one of those. So I get a +2 and a -2. That equals 0. So I only need one of each of those, so I'm just going to write them next to each other. Ones are invisible. SN-SO4, tin 2 sulfate. Okay, so that's it. That's all you do there. Writing ionic compounds, or writing the formula for ionic compounds requires a little bit more work because you have to figure out how this is an absolutely necessary step. Okay, the name doesn't tell you anything about how many there are, so you have to figure that out to be able to write the formula correctly. Okay, if you need more examples or you're not sure what to do, make sure you talk to your teacher. Thanks for watching.